Okay, for a rectangular hyperbola, so the simplest hyperbola has equation fx equals to 1 on x, which you have the equation like the graph like this, and you have asymptotes. The asymptotes is on the x-axis and on the y-axis. Even though they're on the axis and y-axis, you still need to sketch that. So you need to label that clearly here. Okay, you have asymptotes here, and you have asymptotes here. Okay, so you need to sketch them, even though it's on the x-axis and y-axis. Okay, so last year you have learned that. So what's the feature of this graph? You have asymptotes, x equals to 0 and y equals to 0. What is the domain? The domain will be r except 0. You have r except 0, and the range is r except 0. And r except 0 for range as well. Okay, so what is the general equation for a hyperbola? The general equation will be a over x minus h plus k. Okay, first thing I want to talk is the asymptotes. So what is the asymptotes? Okay, the asymptotes is the value you cannot take. Your value can approach into that, but you can never take that value. So what value we cannot take for x? Remember the implied domain. The denominator cannot be 0. Okay, denominator cannot be 0. So when denominator equals to 0, that value will become asymptotes. Okay, that value will become asymptotes because your denominator cannot be 0. So when it is 0, that value will become the asymptotes. You cannot take that, so that's the asymptotes. And also the value you add at the back, that will become asymptotes. That is the y asymptotes. Why that will become the asymptotes? Because it's k plus the fraction in the front. That fraction can never become 0. Okay, that fraction can never become 0. Because you have a divided by something, a divided by, no matter what you divide, it cannot be 0 for sure. So k value is the asymptotes because you can never get k. So k is the horizontal asymptotes and x equals to h will be the vertical asymptotes. So the next thing we're looking at, like we first of all when we draw the graph, we first will make sure what's the asymptotes. Okay, we sketch asymptotes first. And the second thing is we want to know the graph is the direction of the graph. It's either in those two parts or it is in those two parts. Okay, I want to know which one. Choose one from those two. Okay, it's either a positive or a negative one. So what value we look at? We're looking at the a value. So if a is greater than 0, we will have that. If a is smaller than 0, we will get this one. Okay. Remember that is not the axis and the y-axis. This is the asymptotes. Okay, it's either in the first and third part of the asymptotes or second or fourth part of the asymptotes. So it's talking about the asymptotes. Okay, so when we know that, we can start to sketch the graph. So we need to find x and y intercept as well. Okay, we need to find x, y intercepts as well. We always can find x, y intercepts. So we'll number 3 find that. Or you can swap number 2 and number 3. Okay, it doesn't really matter. So let's do one example. So 1 plus 2 minus 3. Y and x. So x plus 2 cannot be 0. X plus 2 cannot be 0. So when it equals to 0, that will become the asymptote. So x equals to negative 2 will be the asymptotes. And you need to write x equals to negative 2, label that. Okay, you need to write out the equations. And the next thing you have is minus 3. Okay, why you have minus 3? Because you minus the 3 at the back, so you will never get those values. Okay, you have that. Y equals to negative 3. Y equals to negative 3. And the next thing you will think about is the A value. A value is the number on the top, whether it's positive or negative. It is positive. So when it's positive, I will have the graph looks like this and this. Okay, to not sketch it, you can see the xy intercept. So let's find xy intercept first. When x equals to 0, y will be a half minus 3, and y will be negative 5 on 2. Okay, so you have the point here, 0, negative 5 on 2. And when y equals to 0, that will equals to 3. 1 equals to 3x plus 6 minus 5 equals to 3x. X equals to minus 5 over 3. Okay, minus 5 over 3. So we have the point here, which is minus 5 on 3, comma 0. So when you draw the graph for asymptotes, the end must be parallel. Okay, the end must be parallel to the asymptotes. Okay, and get close enough and parallel to the end, which means it's approaching but not far away, not get onto it. Okay, do not hit the asymptotes. So for this side, we will have, let's extend that, and we'll have this part of the graph. We better label one point on this graph. Okay, we better label one point on the graph. For example, I can label negative 3. Let's say that's negative 3, so that will be negative 4. So substitute x equals to negative 3. Y will be 1 over negative 1 minus 3. Y will be negative 4. Why I do that? Because I haven't got any point on the second half of the graph, so better give a point to say, okay, that belongs to this graph, to this function. Okay, so now we talk about the domain. Okay, what's the domain? The domain will be R except negative 2. And what's the range? The range will be R except negative 3. Okay, R except negative 2, and range is R except negative 3. Because Y cannot take negative 3, so the range is everything except negative 3. The asymptotes will be the value you cannot take. Okay, so domain is R except negative 2 and range is R except negative 3. Let's look at the bottom one first. Okay, let's look at the bottom one first. So at the bottom one, so you want to find out what is the asymptotes first. Okay, the asymptotes is the denominator equals to 0. So 2x minus 4 equals to 0. 2x will be 4 and x will be 2. So for the bottom, asymptotes will be x equals to 2. And y equals to 1 is the other asymptotes. Y has x, y equals to 1, equals to 2. Y equals to 1 and x equals to 2. The asymptotes, and you can find xy intercept. So find xy intercept when x equals to 0, y equals to 1 minus 3 over negative 4, y equals to 7 on 4. Which is here. And the next one is finding when y equals to 0, y equals to 3 over 2x minus 4, 2x minus 4 equals to 3, 2x equals to 7, x equals to 7 on 2. The point is here. And you can see which two part I should have graphed is the second and fourth quadrant. But like if we see here, that is fx equals to negative 3, 2x minus 4 and plus 1. So the a value is negative. So it should be in the second and fourth quadrant. So my graph will look like parallel in the end and parallel in the end. So that point is 7 over 2 comma 0 and 0 comma 7 over 4. Now we talk about domain. Domain will be R except 2 because I cannot take x equals to 2. And the range will be R except 1 because that's the y value I cannot take. Next one is a special one because it not looks like a hyperbola. Okay, it not looks like a hyperbola, but I will give you a note that say linear on linear is a hyperbola. Okay, the note is linear on linear is a hyperbola. So you can make the form become a hyperbola. Okay, even though you can't see like that's a hyperbola, but you can do it. Two ways to do it. You can first do long divisions. Or second, you can do like by looking at it, and so I'll show you the second method first. Say we have 3x minus 4, I want a blue pen, 3x minus 4 over 2x plus 1. So what I'm trying to do is, I will keep the bottom as whatever I have is 2x plus 1. Okay, what I will write on the top? On the top, I will still write 2x plus 1. But have a look, I need 3x. Okay, I need 3x. 2x plus 1 is not good enough. So I will make the same number of x. So what I will do, I will divide the 2 here and times a 3. Okay, now that becomes 3x. Okay, that becomes 3x. And now next thing I'm looking for is the constant value. The constant I need a minus 4. But what I have at the moment, I have a plus 3 over 2. Because if you open the bracket, you have a plus 3 over 2. So you will subtract the 3 over 2 and then put the constant back. Okay, that's what I'm going to do. So I have 3 over 2, 2x plus 1 minus, that's 11 over 2. Okay, 8 plus 3 is 11, so it's 11 over 2. And the whole thing divided by 2x plus 1. And now I can separate that as this. And subtract 11 over 2 over 2x plus 1. So what I have here is 3 over 2 for this and minus 11 over 4x plus 2. Okay, times 2 on both top and bottom. And can you see that's a hyperbola form? Okay, that's a hyperbola form. And that will be minus 11 over 4x plus 2 plus 3 over 2. Okay, that's a hyperbola form. Okay? No. No. Yeah. Yeah. If you can really see it, like it will be really quick because I'm showing you, so I'm showing you all the steps. If you can see this method, you can understand this method, can be really quick to do it by this way. Or like what you do is long division. So if you're not good at the previous one, you can do that, divide by that. So 3x divided by 2x, you have 3 over 2. So times that back, that's 3x plus 3 over 2. Okay, you will subtract minus 4, subtract 3 over 2 is minus 8 on 2, subtract 3 on 2 is minus 11 on 2. So the whole part is 3 over 2. So this divided by that will be 3 over 2 subtract 11 over 2 on 2x plus 1. Okay, that will give you the same result. And that is 3 over 2 minus 11 over 4x plus 2. That will be the same. Okay, you can choose your own method. Like long division is also easy to make mistake. For example, the minus subtract the positive, or like if you subtract the negative, that will be a plus. So just be careful about that. Okay, now I have made the form back into hyperbola form, and now I will find my asymptotes. My asymptotes will be 4x plus 2 equals to 0. X will be negative a half. Okay, solve for that, and that's negative a half. And y equals to 3 over 2 will be another asymptote. And now let's find xy intercept. Okay, even though you rearrange the equation, you make that looks like hyperbola form, but like you still can use the original equation to find xy intercept. To find x-intercept will be when y equals to 0. So if you solve when y equals to 0, let's put that back into the original equation. So it's 3x minus 4 over 2x plus 1. That equals to 0. And it's really easy to have 3x minus 4 equals to 0. It's easier than you put that into the, like this form, into the top form. Okay, it's easier than you put that back to here. So x equals to 4 on 3. So the x coordinates is 4 on 3, comma 0. Okay, to find y-intercept will be when x equals to 0. When x equals to 0, then it's minus 4 over 1. That will give you 4. Because if you put 0 back to here, so it is 3 times 0 minus 4 over 2 times 0 plus 1. And that is minus 4. So y equals to minus 4. So it's 0 minus 4. Any questions? No? Okay, now let's put all the information graph. Asymptotes is y equals to 3 over 2, which is here. We have y equals to 3 over 2, and x equals to negative a half. X will be negative a half. And the y-intercept is 0, negative 4, which is here. Okay, let's see this graph. You know that's a negative, so it will be in this quadrant and in this quadrant. So if in those two quadrants, okay, do not draw it yet. I definitely have a graph looks like this, but in this quadrant, let's have a look in this quadrant. I can have graph from here to here. Okay, I can have one positive x-intercept and a negative y-intercept, or I can have a graph like this. Can you see the difference? I have a negative x-intercept and a positive y-intercept. Both ways is correct. So before you find out the x-y intercepts, you won't know which one will make sense. Okay, you won't know which one makes sense. So we have the y-intercepts -4 now. So we have the point here. Okay, that's one point. And have x-intercept is 4 on 3, which is here. So the other one's here. So the graph will look like this. Okay, that's 0 minus 4, and you have 4 on 3, comma 0. And let's draw better for this one. Better to find another point. So which point we can find? Let's find -1. So when x equals to -1, 3 times -1 minus 4 over 2 -1 plus 1 equals to -3 minus 7, and that's -1 plus -2 plus 1 is -1. That will be 7. So that is 1 and 7. -1 and 7. Okay, so the domain will be R except -1/2, and range will be R except 3/2. Oh, not curly bracket. Okay, you have curly bracket 3/2. Okay, that's for hyperbola. So I have shown you 3 types of hyperbolas, and remember, linear on linear will be hyperbola. This is a really useful concept. You use that a lot in year 12. You use that a lot in year 12. So remember that. Linear on linear is hyperbola, and how to make that looks like hyperbola.